All right, class, if I can have your attention, please. We are taking a look at chapter 6.6. So here's the homework in advance. There's going to be a new video here, 6.6 lesson, as I record this right now. So let us begin. So 6.6 is general form of the equation for a linear relation. So we've been exploring different forms of linear relations. So remember, linear is a straight line, points that form a perfectly straight line. That is linear. We've talked about y equals mx plus b form. Remember that one? Yeah. We've also talked about what? What's another form we've talked about? Slope. Well, that was the slope y-intercept form. Y equals mx plus b. What was the other one? Point slope. Point slope. That's the y minus y1 equals m times x minus x1. Remember that one? That was the last one. We're going to learn about two more forms today. Specifically, the general form is what we're going to kind of work with and land on. That's a very popular, common form of a linear equation. In high school, the most common one is the y equals mx plus b, the slope y-intercept form. That's the most common. But we need to know about other forms as well. And the nice thing about this is the other forms are just rearrangements kind of thing of y equals mx plus b. The only thing with general form is, and I'll get to in a second, but there's no fractions in general form. So if there's a fraction for a slope or a fraction for a point, like in y equals mx plus b, then you have to get rid of the fractions and rearrange the terms a bit to put in general form. I'll get to that in a second. First, what we want to learn about is standard form. Okay? Now, here's a straight line, the red graph. The red line is a straight line. And you may never have seen this type of an equation for a line. 2x minus 3y equals 12. Okay? So this is called the standard form of a line. Okay? Standard form. Now, what is it about standard form that is characteristic of standard form? Well, the coefficients and constant terms are all integers. So there's no fractions, okay? So there's no fractions. So standard form, there's no fractions, okay? The x and the y terms are on the left side of the equation, okay? On the left side of the equation. So you see 2x minus 3y. You see them both on the left side. And the constant term is on the right side. Okay, so if you're okay, so let's write it like this. Okay, so a x plus b y equals c. Okay, that is standard form with a, b, and c as your coefficients. Okay, and again, coefficients. If you're unsure about that word, coefficients, the number. No variable, the number that's multiplied by a variable, okay, of some sort. Okay, so the coefficients are a, b, and c. So a is an integer, b is an integer, c is an integer. There's no fractions. X and y are on the left side, and usually we write the x term first and the y term second. Okay, now I believe it's not written here, but I believe that for standard form 2, and we should write this down. I'm just going to double check this. Okay, so a also in standard form, it's not in the textbook, but a should be a whole number, so not negative. Okay, so a is not negative. A is not negative. Okay, it's it's technically a whole number. It could be 0. Keep it that way now. Just put it away. Please. Yeah. Okay, so a is going to be positive. All right, cannot be negative. And listen, if a is a negative value, you can just rearrange the equation, put the a term and all the rest and the y term on the other side, and the constant move it over. Because b could be negative, c could be negative, but a should be positive. Okay. So this is standard form, constant on the right. And remember that this is still a description of how the x and y coordinates, how they relate to each other. Okay, so every point on this line if you put the x value of the point and the y value of the point, if you put it into this equation, it'll make the equation true. So just for an example, this point, what is this point right here? It's the point what? 6, 0. That's the point 6, 0. So if I put x equals 6 and y equals 0, this should be a true statement if it's indeed the equation of this line. Well, that's 12 minus 0 equals 12. Does that work? Yep. Yeah, look at that. Okay. So other ones, we won't do many, but I mean you could do the other intercept. Okay. 2 intercepts are easy to find, so I kind of like focusing on the intercepts. This point is 0, -4, isn't it? So look at, if I put 0 in for x now, and -4 in for y, this is 0 minus -12 equals +12. Does that look right? Yeah. Negative and a negative is positive. Okay. So this is an equation for this line. And yes, we can rearrange the terms. If we do everything like algebraically proper, we could change the order of the terms and we could move everything over to one side. You could solve for y and have y by itself on one side equals, and then the mx plus b form, and it'll still be the same line. So we can write an equation for a line in a lot of different ways. All right, now if we go ahead and take this equation in standard form and I move the constant over to the same side as the x and y terms, it looks like this. Can everyone see that? My computer's not behaving, but can everyone see that right here? So if you move the 12 over to the other side or subtract 12 from both sides, you get this. Now this, when this equals 0, so you have nothing left on the other side, you have to show something that equals 0. This is general form, the form that we want to focus on today. Okay? So what is it with general forms? Very similar to standard form, except the constant's on the same side. So here is general form, and you should write this down in your notes too, please. General form of an equation, ax plus by plus c, all on the left side, equals 0. And here's where they make sure that they say that a is a whole number and b and c are integers. So again, there's no fractions here as well. Okay, no fractions. And if you end up having a fraction in your equation, you're like, oh no, this is not in general form, I can't have fractions, what do I do? Anybody know what you would do if you had a fraction as one of your coefficients? How would you get rid of it? Or how would you change it a little bit?
Turn it into a decimal.
Okay, you can turn it into a decimal. There's no fractions. But technically, we don't want decimals either, because decimals are just like other ways to write a decimal, or write a fraction. So no fractions. Thank you for saying that, though. We should say no decimals either. So they have to be whole number for A and integers for C. So if you wanted to get rid of a fraction like 1/2 A, what would you have to do to get rid of that fraction, or to write it in a different way? You'd have to multiply everything by what?
The denominator.
Yeah, by whatever the denominator is. That's right. Yeah, you multiply everything by that. And we'll do some examples there. But you can rearrange, or you can change the equation how it looks without changing the actual line. Okay, so here are some questions where we're going to do exactly that. All right? Now, write each equation in general form. So this is in slope-intercept form, right? Slope-intercept form. And we love that one. And that's very popular in math and science. But I want to write this in general form. So the first thing I'm going to do is I'm going to get the x and the y and the constant all to the same side of the equation. I can easily move things over to the left side. So this is what I'm going to do first. I'm going to add 1/4 x to both sides, right? Because I want to get the x and the y terms on this side. So I'm going to put 1/4 x, and then this is a plus y, right? That's a positive y, so I'll write plus y, equals 3. That's my first step. Now this is standard form, or close to standard form, but I want general form. So I'm going to get all of the terms over to the left side. So I'm going to have, next step would be this, 1/4 x plus y minus 3 equals 0. Do you see how we're kind of moving towards general form here now? Okay, So moving all the terms is one thing. Second thing I want to do is I want to check to see if this coefficient is positive and a whole number. So is it positive? Yes. So I'll just leave that alone. Is it a whole number though? No, it's a fraction, right? So as mentioned before, we can multiply both sides of the equation by any number we want, and it won't change the relationship between the sides. So again, if you have, let me just give you an example of that. If you have like 1/2 x equals 4, okay, and I go ahead and I multiply both sides by 2, all right, if I do that, the same thing to both sides of an equation, I now get x equals 8. Okay, now going back to my original equation, is x actually equal 8? 1/2 of something is 4. X is 8, right? So this is how you solve for x. That's how we've done this before. So multiplying both sides of an equation by the same thing is totally fine. It does not change anything about the equation. It just changes how it looks. So I could, like, really this equation, and this equation, x is the exact same, right? It just looks different. Okay, so going back to my equation, I am, as was suggested before, going to multiply all the terms, everything on both sides of the equation by 4 so that I can show this x term without a fraction, okay? And I will write this out so that the long way so you can all see it. So I'm going to do this, 4 times 1/4 x plus 4 times y minus 4 times 3 equals 4 times 0. I'm going to multiply 4 by everything. And I'm not going to change the nature of the equation at all. So this is the nice part though, 4 times 1/4, that's like 4/4, which is 1. Okay, so this is just 1x, or I'm just going to write x there. This one is obviously 4y, I have to keep that. This is minus what? 12 equals, now what's 4 times 0? 0. Still 0. That's the nice thing about 0. You multiply by anything and it's still 0. You divide it by anything except for 0 and it's still 0. So multiplying 0 is not a problem. Question? Quickly. Yeah. All right, so now I've got everything over to one side. My x term, the coefficient is positive and it's a whole number. So am I done? Do you think I'm done? I've got everything over to one side. I've got 0 on this side. I've got a positive whole number for x. I am done. This is your final version. This is your general form of this one. Okay? Now they look very different, don't they? They look very different, but they are the same line. They're exactly the same line. Okay, let's do this one now. Okay, this one looks like a real mess. It's not so bad. This is the point slope form, right? Point slope form. Because I can see a point that's on the line. I can see that it's 4, -2. 4, -2 is on the line, and the slope is 3/2. That's what you can pick out from the point slope form, right? So what we're going to do is we're going to multiply this number into the brackets to get rid of the brackets, and then I'm going to get everything over to the same side. I'm going to make sure that a is positive whole number. Done. So we are going to expand this out because you don't like brackets. You gotta gather like terms, so get rid of the brackets. So I'm going to rewrite this, and this is going to be 3/2x minus, what's 3/2 times 4? Well, you can do 3 times 4 is 12 divided by 2 is 6. Or you can do 4/2 is just 2. So 3 times 2 is 6. Either way, that's how you multiply those things. Okay. All right. Now, when you get to this point, you have some options. Some of you will like to get rid of the fractions first and just do that all, like get rid of the fractions early. And then it's easier to gather like terms, and it might be, because you don't want to add, subtract fractions if you don't have to, I guess. So I'm going to do that. I'm going to multiply everything by 2, because that's the number that's in the denominator. And if you had more than one denominator, you would multiply by the lowest common multiple of the denominator, and you should remember that from chapter 1. Okay, so I'm going to multiply everything by 2 here. So 2 times y is 2y. plus 2 times 2 is 4 equals 2 times 3 over 2. Well, that's 6 over 2 is 3, right? Or 2 and 2 cancel out, top and bottom, and 3x. Minus 2 times 6 is 12. Okay, everyone okay with that step, what I just did over there? Yeah? Any questions? Okay, now we've got whole numbers for everything, or integers at least. So now I want to arrange everything so that the x, the y, the constant are all on the same side of the equation. And if you notice something, okay, there's two things you could do here too. You could get all these terms to the left side, because that's where we want them, on the left side. But if you move 3x over the left side, that's going to make it negative. You see that? So what you could do is just say, I want this x term to be positive. It's positive on this side, so I'm going to bring everything else over to the same side as the x. It might, will it save you a step later? Maybe. Okay. So yeah, I'm gonna do that. So I'm gonna say, let's get this term, let's subtract 2y from both sides, and I'm gonna get this term over, let's subtract 4 from both sides. So I'm gonna be left with 0 over here equals the 3x. I'm gonna leave that there because I didn't add anything to it. Now I've got negative 2y, right here. These are gone. And I've got negative 12 minus 4 is negative 16, right? You go back 12 and then you go back 4 more, you got negative 16. Okay, so this is great. I would make sure that you have, just to simplify things, make sure that you have all of your terms on the left side like the book has said, because you're just learning this. So put everything on the left side, the 0 on the right side, because that's what the answers are going to look like in the book. That's what standard form is. It means the same thing, but again, let's put it in proper order. So if you move everything on this side over to this side and everything over here onto this side, you don't have to change any signs. So we're moving everything over. We're just rewriting this as 3x minus 2y minus 16 equals 0. Then you're fully done. Okay? So because we're just learning this stuff, I would suggest please make sure that all the terms are on the left side, and they're whole numbers or integers for B and C, and that the A is positive there. Okay? All right. Question? Yeah? Where did 3x come from? This 3 over 2x times 2. Because I distributed this 2 to every single term up here. So 3 over 2 times 2 is like this. 3 over 2 times 2, or 2 over 1. The 2's on the top and the bottom cancel out. They divide out to give you 1, so that's just 3. Or if you want to think of it this way, if you don't like the dividing out there, 3 times 2 is 6, divided by 2 times 1 is 2. So that's 3.
Can't you also, like the 3 over 2, can't you move it to the other side before you...
Yes, yeah. Okay, so I multiplied everything to get rid of the denominator first, pretty much first step after multiplying out the brackets, right? As I mentioned, you can move all the terms first and then multiply later. Yeah, totally. That's totally fine. Totally fine. You should get the same answer. Yeah, because in that way you'll be able to combine like terms first. So that's a positive thing too. Anyways, all right. You know what? Let's do one more example here. I just feel like you guys should maybe do one example a little bit on your own. So let me just ask you this, okay? So here's an example. Write this down. Let's do 2y equals 1/3 x plus 5. Turn this one into general form, okay? General form is, okay? So you guys go ahead and do that on your paper right now. Where's your paper? Okay, get your paper up. Yeah, you're supposed to be taking notes, remember? Okay, take a minute and do that. Okay, let's walk through this answer and see if this is correct. The way that you did this may be different than what I did, because I did the opposite way now. So what I did was I moved everything over to the left side first before I multiplied. That's what I did first, which means that this 1/3 x becomes a negative 1/3 x on the other side. Then I subtracted 5 from both sides, and the 2y was already over there, so I left it. Okay? So you could do it this way too. Then what I did was I multiplied everything by 3. By 3. And 3 times negative 1/3 is negative x. 3 times 2 is 6. 3 times negative 5 is negative 15. Okay, that's what I did next. Then I realized that I'm so close, but the a value here, the coefficient on x, is negative 1. So I don't want a negative. So how do you fix that? Well, you either multiply everything by negative 1 to get rid of the negative, or you divide by negative 1. It's the same thing. So some of you see that coefficient and maybe you want to divide. So you divide by negative 1. And you do that to each term. Or you multiply by negative 1. It's the same thing. And so basically you change the sign of all of the terms. You make the sign opposite, and this is where you get this as an answer. Okay? Any questions about that? That make sense? Okay, do you think you could do that on your own? No? Yeah, no. Okay, well, half and half? All right. Okay, let's keep going here. Determine x and y intercepts of the line whose equation is. Okay, copy this example down. Okay, this is example 2 in your textbook. We are going to determine x and y intercepts for this line. And then we're going to graph the line. And this actually is going to be real easy. Okay, real easy. So please jot this down quickly. Here's your equation. Determine x and y intercepts. Okay, so in determining intercepts, do you remember we talked about this a little bit, like how we find an x-intercept, let's say? What do I have to do if I want to find x-intercept? Anybody remember yet?
I remember that if it was like the 18 was on like the right, like the other side of the equal sign, and you'd have to like cover the 2y.
Okay.
And like if it was like 3x equals positive 18, then you know that x, you'd have to divide 18 by 3, and you get 6.
Okay. All right. So, yeah. So to find the x-intercept, you said cover up the y term. Okay. Yeah. Cover up the y term is letting y equal 0. That basically covers it up, right? You can cover it up, literally. But yeah, you let y equal 0, solve for x. Okay. That's how you find the x-intercept. So that's what we'll do. So 3x, I'm going to solve for that x, plus 2 times 0 minus 18 equals 0. So let y equal 0, then solve. So this, now I have 3x minus 18 equals 0. I need to get x all by itself, so I'm going to add 18 to both sides. So 3x equals 18. X equals 18 divided by 3, or x equals 6. Okay? So x equals 6, so my x-intercept is the point 6, 0. And remember, I really want you to write the intercepts as points, 6, 0. Okay, that's your x-intercept. The y-intercept, you let what? How do you find the y-intercept? Let x equals 0, and then solve for y. Okay, so that's awesome. So let's do that. So 3 times 0 plus 2y minus 18 equals 0. And that is gone. That equals 0. So this is going to be 2y minus 18 equals 0. I'm going to get y all by itself, so let's get rid of the 18. 2y equals positive 18, and divide both sides by 2. I get y equals 9. Now that means that the y-intercept is the point 0, 9 with the brackets around it. Does that look good to you guys? Everything looks okay there? Okay, awesome. Awesome. Okay. All right, so it says graph the line now. So now that I have the intercepts, it's actually really easy to graph. So I'm just going to make a little XY coordinate there. So 2 points I'm going to put on there, and they're easy. 6, 0. So I'm going to go 1, 2, 3, 4, 5, 6. I'm going to put that point right there. And I got to go up 9, So I'll make these a little smaller. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's my 9 right there. And then you take your ruler or straight edge that everyone's bringing to class and to all quizzes and exams now, of course, and we are drawing our line. Connecting the 2 points, right? Cool. Now, is there a way that you can check to see if you've done this correctly? Or there are ways, but does anyone have an idea of how you could check to make sure that you've done this correctly?
You find the slope.
You find the slope of the line. Okay. Now, if you found the slope of this line, how would that tell you whether you've done this correctly or not? Like, do you see the slope here?
Y equals mx plus b.
Okay. You could change it into y equals mx plus b, and then you could actually check 2 things. You could check the y-intercept, make sure that the b is 9, and if you found the slope, it should match up with the slope in the rearranged equation. Absolutely correct. That's absolutely correct. Okay, so I'm going to do that. That's a great suggestion. So I'm going to do that. So 3x plus 2y minus 18. Okay, 3x minus 2y, nope, plus 2y minus 18 equals 0. So I'm going to change this to y equals mx plus b, which you have to do anyways. You have to know how to do that. So I'm going to leave the y term on the left side, so I'm going to get rid of everything else. That means I'm going to add 18 to both sides. That means I'm going to subtract 3x from both sides. So I've got 2y equals negative 3x plus 18. And then I'm going to divide by 2 everything so that I get y. 2's are gone. So I'm going through this pretty quick because you guys, this should be just review. Now look at this. Negative 3 over 2 should be my slope of this line. We're going to check that in a second. And then 18 over 2 is plus 9. So this is in y equals mx plus b form over here. And I'm going to check to see if the slope and the y-intercept matches up. The y-intercept I already see matches up. That's awesome. What's the slope of this line? The slope of this line. The slope is from the point on the left to the point on the right. I'm going to go down how many units? Down -9. And then to the right, 6. What does this fraction simplify to if I divide everything by negative 3 over 2? So does that line up with what I have in my rearranged equation? Boom. So what that means is that this is our correct answer right here. No. What that means is, what did I do? Oh, that means, yes, that's the question. That means that this graph is accurate, right? Because it should be the same line for all versions of all forms of the line. The same line should be the same for different correct versions. Okay. Does that make sense, or is that confusing? Anybody have any questions about any part of this? Yes.
How did you get -9 for m equals negative?
Oh, okay. So the slope here is going down from left to right, right? So we know it's a negative. How do we find that out? If we take a point on the left side, which we usually do, we usually take a point on the left and a point on the right, and then we either go up or down to get to the next coordinate, and then we go left or right to get to the next coordinate. Now, if we always start with the left, we're always going to go right. So if you have to go down, that translates into a -9, a rise of -9. So if you have to go down, that's called a negative rise. Okay? So that's -9 because you got to go down to get to the second point. And then you have to go right, positive 6 units to get to the second point. Does that make sense? Yeah? Good. Any other questions? Okay, you guys are awesome. Okay. One more, and then I'll give you your assignment to work on. This example says determine the slope of the line for this equation. Okay? So go ahead and write this down, write this equation down, and I'll show you how to do this. Okay? 3x minus 2y minus 16 equals 0. Okay? Write this one down. Yeah, write this equation down, everyone. Okay, so right now, what we're going to do is we're going to change this into y equals mx plus b form, because then I will be able to see exactly what the slope is when I look at the number in front of the x. Okay, so this section is about changing forms from one to the other so that we can see the different information that those forms show us. And I'll show you a shortcut in this kind of thing at the very end. So I want to get the y all by itself and positive. So I'm going to leave the y on the left side. I'm going to get rid of this term and this term to the other side. So I'm going to subtract 3x, and I'm going to add 16 to this right side. Okay, that's the opposite of what I have here, minus 3x and then plus 16. So I'm left with negative 2y equals negative 3x plus 16. And now I want y by itself and positive. So guess what? I'm going to divide off the negative 2. And as long as I do that to both sides, I'm fine. So negative 2 divided by negative 2 is just 1. That gets me the y all by itself and positive. That's exactly what I want. Now here's the key. What is this term when I simplify it? Positive 3 over 2x, or 3x over 2. They're both the same. And then what about this one when I simplify it? That's going to be negative 8 or minus 8. Very good. So that is, you've changed the general form into y equals mx plus b form. And so then our slope is positive 3 over 2. Excellent. Okay, so that's one way. And I think, let me just see if it's in this section or not. Okay, so what we have to do is we have to get y by itself. So guess what? This x term has to go to the other side. So this coefficient of 3 is going to be changing signs, right? This was a positive 3 over here. It's now a negative 3 over there. Then we divided by the coefficient on the y, you see, right here, to get the slope. So if you take the negative value of the a term, that's the term on the x, and you divide it by the b value, every time from the general equation, that's how you will get your slope. So negative a over b. Negative a over b. And if you look carefully here, negative a would be negative 3, and b is negative 2. So negative 3 over negative 2 is 3 over 2. So from the general equation, this is a shortcut to finding the slope. And that may come in handy. Okay, so you can jot that one down. And a and b are the coefficients in the general form. Okay, so just given the time, oh boy, there are some word problems in this section that I probably won't go over. There's one on page 382. I don't know. A big thing is the intercepts here, guys. When you're given general form, finding the intercepts is really easy, right? X-intercept, let y equal 0, so just like eliminate the y term and solve for x. And to find the other one, you eliminate the x term and solve for y. So those are really easy to find, and that's kind of a strength of this version. But let me get you to your assignment. Okay, there's your assignment from the textbook. Starts on page, looks like 384. Page 384. The first one asks, in which form is each equation written? So you're just trying to look at the form and identify whether it's slope-intercept, point-slope, or general, or even standard. Okay.
Four to 7.